Welcome to episode 19 of my calculus series. Today, we're exploring integration by parts, a powerful tool for tackling integrals that basic rules can't solve. But before we get into it, if you're enjoying these episodes, a like, follow on TikTok, or subscribe on YouTube would really help me keep making more lessons like this. Alright, let's get started. Some integrals can't be solved using just the basic rules. For example, the integral of x times ln x, with respect to x. This is where integration by parts comes in, a technique based on the product rule for derivatives. We start with the product rule. The derivative of uv with respect to x equals u times dv, dx plus v times du, dx. If we rearrange and integrate both sides, we get the integral of u dv equals uv minus the integral of v du. This is the famous integration by parts formula. Integration by parts says, the integral of u dv equals uv minus the integral of v du. We choose part of the integrand as u and the other part as dv, then compute du and v. A helpful strategy is the LIATE rule, L for logarithmic, I for inverse trigonometric, A for algebraic, T for trigonometric, E for exponential. You typically choose u as the first type that appears in this list. Example 1. Let's evaluate the integral of x e to the x. We set u equals x and dv equals e to the x dx. Then, du equals dx and v equals e to the x. So, the integral becomes x e to the x minus the integral of e to the x dx, which equals x e to the x minus e to the x plus c, or factored as e to the x times x minus 1 plus c. Example 2. Let's evaluate the integral of ln x, for x greater than 0. We take u equals ln x and dv equals dx. Then, du equals 1 over x dx and v equals x. The integral becomes x ln x minus the integral of 1 dx, which is x ln x minus x plus c. Example 3. Evaluate the integral of x squared sine x. Let u equals x squared and dv equals sine x dx. Then du equals 2x dx and v equals negative cosine x. That gives negative x squared cosine x plus the integral of 2x cosine x dx. We apply parts again. U equals 2x, dv equals cosine x dx, so du equals 2 dx and v equals sine x. That integral becomes 2x sine x minus the integral of 2 sine x dx, which is 2x sine x plus 2 cosine x. Combining, our answer is negative x squared cosine x plus 2x sine x plus 2 cosine x plus c. Example 4. Let I be the integral of e to the x cosine x dx. We integrate by parts. U equals e to the x, dv equals cosine x dx, so du equals e to the x dx and v equals sine x. I equals e to the x sine x minus the integral of e to the x sine x dx. Call that second integral j for j. We set u equals e to the x, dv equals sine x dx, so v equals negative cosine x. That gives j equals negative e to the x cosine x plus I. Substituting into the first equation, I equals e to the x sine x plus e to the x cosine x minus I, so 2I equals e to the x times sine x plus cosine x. Therefore, I equals 1/2 e to the x times sine x plus cosine x plus c. Example 5. Let's evaluate the integral from 0 to pi of x sine x dx. Set u equals x, dv equals sine x dx, so du equals dx and v equals negative cosine x. The integral equals negative x cosine x, evaluated from 0 to pi, plus the integral from 0 to pi of cosine x dx. The first term is negative pi cosine pi minus 0 cosine 0, which is negative pi times negative 1, giving pi. The second term is sine x from 0 to pi, which equals 0. Final answer, pi. Example 6. Let's evaluate the integral of x cubed times e to the x using tabular method. We differentiate x cubed repeatedly and integrate e to the x repeatedly, then multiply diagonally with alternating signs. This gives e to the x times x cubed minus 3x squared plus 6x minus 6 plus c. Exercises 1. Evaluate the integral of ln squared x dx. Hint. Let u equals ln squared x, dv equals dx, and use parts to reduce the power of ln x. 2. Evaluate the integral from 0 to 1 of x ln x dx. Hint. Let u equals ln x and dv equals x dx. Summary. Integration by parts helps integrate products. It comes from the product rule and uses the formula. The integral of u dv equals uv minus the integral of v du. Use the LIATE rule to choose u and dv effectively. And that wraps up episode 19 on integration by parts. If this helped you out, don't forget to like, follow, or subscribe so I can keep making more lessons like this. See you in the next one.